consider it called that for the rest of the talk. But JavaScript came out and was and is now ubiquitous and is now the basis of a huge amount of stuff to come. But and PHP came out, which I'm very excited about. And so, but from the point of view of change, being a new language, which should completely change the world. But now, somebody looked at JavaScript and thought it could be more Python-like, or wrote CoffeeScript, and there's a whole bunch of people saying that the whole weaken type language world is wrong, and you should. And there's the Scala contingent who are building on the JVM and building a strongly typed language, which is all new and exciting, different, and illegible to people who haven't got into Scala. And but potentially, and there's all the same things. Remember, the idea that actually you could configure this so that you could write things really powerfully, express things really powerful things very concisely. And we will get the computer to do more work for us. The computer will test more things, so we'll get fewer bugs. And so it's great that people are excited about languages again. Okay, so there we. But now where we are, in fact, is that we've come to this place where JavaScript is and everything, we build everything on JavaScript, but we've come through it through declarative languages. The web worked because HTML didn't say anything about the platform you're on, and it didn't tell you what programming you should implement it in, what programming language you should implement HTML in. The idea was it would be ubiquitous. But I had to define HTML and HTTP and URLs. The idea was they should all be, they had to be universal. I wanted people to be able to put anything on the web, and that meant I had to ask for as little as possible. So HTML had to make sense to people who'd used HTML, so that's why the angle brackets, and HTTP had to make sense to people who had used other languages like other protocols like NMTP and stuff. And so that's why it's got RFC82 headers in it, and URLs had to look kind of like file names with the slashes around the right way. And then the computer bit had to be a domain name, because people understood domain names. It would be more logical to put the domain with the most significant bit first, like the Brits did in their domain system, but they had to go through the process of changing. So all of URIs and HTTP and HTML were designed to look like other things, and they were designed to be completely declarative. So that why? Well, declarative is good. Declarative is safe. When you have something like an HTML page, you can do lots of things with it. You can repurpose it, because it's just sitting there saying, this is the heading and this is a list. Then it has lots and lots of uses. It will be read by lots of different things. It will be displayed by different people, different sorts of things, for people who are visually impaired and so on. And it'll be indexed, and it has lots of interesting sort of metadata involved in it. So that the whole, so HTML and CSS as well. CSS, you could have done all this, the styling by just embedding JavaScript early, something like JavaScript early on. But I think there's a huge amount that we benefited from in making it declarative. And so there's this interesting balance between declarative systems and procedural systems. And procedural systems are great, they're powerful, because they allow you to do whatever you like. But they then allow, they are a very powerful language, and there's a principle that I've eventually sort of wrote up and called the principle of least power. That ideally, if you're going to transmit something, you should use the least powerful language you can. And that was largely for architectural reasons, because if you just use a declarative language like CSS instead of sending the code, that's going to last for time, it's going to be more interoperable, and so on. But now, there's a really interesting balance between, if you talk to security people, they will say the same thing, but they will say the same thing, but from the point of view of that Turing-complete languages are a security nightmare, in a way. When you design a protocol, that one machine will send a message across to another machine. If the message is something like it's a set of flags for whether the traffic lights should be red, green, or blue, or if something like HTML or CSS, then it has to be a very bad day for the programmer to have written something which has flaw in it which can be exposed. Yeah, I know apparently there was I understand there was